Okay, good morning, everyone. Welcome once again to the Work in Progress series. This is the second of the Work in Progress series that we have run, and it's a very exciting one. I am personally super excited about this topic because it's about something that is going to affect all of us, which is climate change. So there are so many aspects to climate change. I'm sure it's something you have heard of before, but I am wondering if what are the people doing about climate change? What are the different industries and different professionals doing about climate change? So this is a series where we will go in detail on some of what people are doing. And to start off, we need to understand what climate change is first. So to kickstart that with us, we have a great leading researcher in the field, Professor Azizan, who is with us this morning. Welcome, Professor Azizan.
Thank you very much for inviting me.
And
Pleasure.
Professor Azizan has done so much work in over the decades, studying the weather, studying the climate, studying flooding, studying so many things. I'm so excited that you get to hear from Prof Azizan today. So this Work in Progress series, I just want to give a quick introduction. It's about looking at what professionals are doing currently in their work so that you can understand a little bit about the world. And it's also a great opportunity for you to ask them about how they got into the job that they do. How did they work to become a climate researcher like Prof Azizan? So it's a really good opportunity for you to do that. So if you have any questions, any comments, don't be shy. Feel free to put in the chat box. Good morning, everyone. I'm so happy so many of you are here with us. Jamal, Megalai, Musa, Sidratul, Shanan, Hakim, Valuvan, Musa, Rizna. So many of you. Thank you for coming in so early. So if you have any questions or comments, just put it in the chat box. Later on, during the Q&A, I will put the questions on the screen and Prof Azizan will address them. Okay, and this is brought to you by Weekend Academy, which is an education program where we bring professionals to talk to students about what they do. So I am very excited to get started. I learned so much from Prof Azizan, and I hope you will too. I'm sure you will, actually. So I don't want to keep everyone waiting. Prof Azizan, I will let you take it away.
Okay, thank you very much. So, being also dinosaur, I'm asking Mei to put the PowerPoint there. Well, Mei asked me to talk about global warming and climate change. And before that, I'm the director of National Antarctic Research Center in the University of Malaya, and also a senior research fellow at the Institute of Ocean and Earth Sciences. And also, I'm also a member of the Department of Geography, University of Malaya. So don't not forget my geography department. Next. So when May asks, I say, how do I start? So I guess the best thing that you need to know is, in order to know about climate, you have to know about the atmosphere. That means, you look outside, that's the atmosphere. And the atmosphere is a mixture of gases. So next, May. And May asked me also, why I became a meteorologist. The person who studies weather is called a meteorologist or the storm chaser. And so I got my PhD in meteorology from University of Reading, but there's no meteorology undergraduate course. So you need to either be good in physics or applied mathematics or physical geography in your undergraduate years, and then you go to university. Even you can join my team, or you can go to where I went, Reading or America or in China. Then you take either an MSc in meteorology or PhD in meteorology, and that of course qualify you to call yourself as a meteorologist. That's next. So what does meteorologists do? We look at the weather, and one of the way of why I got attracted of it was because there's this amazing cloud called the morning glory cloud that I'm showing to you, and that occurs somewhere in Cape York in the Cup of Carpentaria, uh, and in one small town called Karumba, I was chasing my morning glory cloud, and basically is a what you call it is a wave phenomena in the atmosphere. So most of the time you think wave occurs in the ocean, but actually waves is also there in the atmosphere, and this cause huge cigar-like cloud, about 2 kilometers thick and about 200 kilometer long. When you talk about 200 kilometer long, you're thinking about the cloud is, like, say, from Kuala Lumpur to Ipoh. How spectacular the cloud is, in terms of, and it moves across from the Gulf of Carpentaria towards the sea. So I was chasing this cloud for my masters, and that was how I got hooked into studying weather and to become a meteorologist. Then I went to do to Reading to do my PhD there, where I was studying on frontal system. Next. So when you want to know about weather, the first thing you just go to the Malaysian Meteorological Department, and there you can see the rate is temperature, and then you have the sun, that's sunshine, then you have cloud with some rain, it shows that you have thunderstorm. And if you look at Malaysia, you see that we have lots and lots of thunderstorm. And I don't know, I'm not sure whether if you are used to be, I got a friend who comes from the Middle East, and when it rains, you can see he was really, really intrigued. And you know why? You can see it when you next one. How spectacular is the thunderstorm? You have all the lightning, and then you have all the heavy rain. Do you know that when you are in UK, if it rains in UK, you can walk to the what you call to the shop. You don't get wet. In Malaysia, if it rains in Malaysia, you just walk about 1 or 2 minutes outside. You'll be wet through and through, and that's some of the difference in terms of how the thunderstorm, how rain occurs in the temperate compared to in Malaysia. Next. And of course, with thunderstorm and with extreme weather, and severe weather, you have high wind. We are lucky that we don't have hurricanes. But if you think about hurricanes, the speed of the wind in the hurricane is nearly about 60 kilometers per hour. So you really cannot stand up. And of course, when you have lots of rain, you have a lot of thunderstorm. You also have flash flooding. So there's quite a lot of interest there. Next. Now, so when you talk about difference between climate and weather, so when you ask the question, how is it going to be today, or what is it going to be next week, or what is it going to be 2 days from now? You're doing some weather forecasting, so that is weather. But when you want to know about climate is actually the average of the weather. So let's say, okay, I'm quite interested. What is the climate like during the ice age period, or when mammals was around, or what is the climate like when the dinosaurs were roaming? So that is also climate, but it's called paleoclimate. You're going back maybe 10,000 years from now, or 40,000 years from now. But people are working on it, because people are also, as much as you want to forecast, as much as is you want to forecast, let's say, what happened in the 21st century, in order for you to forecast it right, you have also to know whether your forecasting is good in 40,000 years ago, and that's how we test whether our model is doing well or not. So that's how the new area of paleoclimate is really quite an expanding area in trying to understand. For your information, the last ice age, when you have the mammoth around, mammals, the last mammoth was around about 10,000 to 15,000 years ago. That was the last of the last ice age. After that, the world warmed up, and now we are in a warmer period. But you imagine then that the mammoth was walking in the earth nearly about 10 to 15,000 years ago, when our great 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 grandfather was still around. Next. Next. Okay, so you have the atmosphere, and atmosphere is actually is just oxygen and nitrogen with small percentage of carbon dioxide. There are not many, so these are all we call trace gases. And the atmosphere is very important because that's where all our weather, and it's also very layered. Next. So it's a mixture of gas, and if you look at this, the blue color is your atmosphere. So it is the most, I think, is about maybe 20 kilometers deep, while the Earth's diameter is maybe 6,000 km. So you can imagine your atmosphere in a way is like a thin skin of your apple. So that is your atmosphere. And and it is the mixture of gas is very much pulled into the earth by the earth's gravity. And the atmosphere is also stratified, that means it's layered, and there are about 5 layers. And all the weather where we live is in what you call the troposphere, which is the one below. So that's all where your weather, where your rain comes from, where your aeroplane always fly. That's where you live, which is about maybe 18 kilometers in our region, and maybe about 8 kilometers in the Antarctic. So it varies in thickness. Next. So if the atmosphere, it acts as a blanket, as it were, the gases. And so we are basically living under this very thin blanket. And if this blanket were to disappear, I mean, just like what happened in the moon, we have no atmosphere. So all of us would die, basically. So so the atmosphere is a very important layer that keeps the Earth alive. Next. So what drives the atmosphere and also life in Earth is the sun's radiation. So I said that the atmosphere is like a blanket. So what happened? You see the yellow light, that is the sun coming in, and then you see the red arrow, and that is what you call outgoing radiation. So we get our heat from the sun, and then what happened? The Earth then export the heat in infrared or long wave radiation. So that's why the outgoing radiation. So when the greenhouse effect, next, right, with greenhouse effect, as you can see, the atmosphere let the sun radiation in, no problem. So you can see, most of the sun radiation, number one, coming in very quickly, and then of course some of it is reflected as albedo. But when it comes to the radiation from the Earth going out, carbon dioxide and methane, this is what you call the greenhouse gas. Hey, you cannot pass. So in order for the Earth to export more, it has to warm up. That means, so that it can export more energy in terms of radiation. And so that's why greenhouse effect actually is a good thing. If you don't have the greenhouse effect, the Earth will be minus 18 degrees centigrade. So Malaysia will be having a weather very much like UK, or somewhere in the mid latitude. So with the greenhouse, the average temperature of the globe is about 15 degrees centigrade. So greenhouse is a good thing. What is bad is that is because we are now emitting more and more carbon dioxide, and we've been doing this since the 18th century. And so in a way, we are making the blanket covering us thicker and thicker, and of course this will make our Earth warmer. And so this is the issue of global warming. is also related to what you call fossil fuel addiction. That means we like to burn coal, we like to burn petrol, we like to burn wood. All of this burning will then produce carbon dioxide, and we've been especially after the industrial revolution, when we switched our energy to coal and then to fossil fuel, we have added lots and lots of carbon dioxide to the atmosphere, and because of that, the Earth is now facing a critical problem known as global warming, and that's because you have a runaway greenhouse effect. Okay, so in order to do that, that's why people are debating about trying to cut down carbon dioxide, because the major component of global warming is carbon dioxide, and of course the other one is methane. Both are being produced now by human beings. Next. Okay, so you can see this one just to show you why the tropic is warmer compared to the polar region, and it has to do with the import and export that I was showing to you earlier. You know, in our and it's also just like what you call day and night, because at night it's cool because you don't have any sunshine, but while in the daytime, in the morning, it starts to have sunshine, and then as time goes, when you have more and more sunshine, then the temperature starts to rise. So you can see the green line is the temperature. You can see the blue line is the export of energy from the at night, and then you see the red line is the sunshine coming in. So just a bit of understanding why tropic is warmer compared to the polar region. Next. So climate has changed, and what I want to show to you is that it is a very strong correlation. In this graph, 0 is now, and then 400,000 years ago is right at the end. So it just shows that climate change is not new. The Earth goes through ice age, and then it goes to interglacial where it gets warmer. So changes in the Earth, is just between 2 degree warmer or 3 degree warmer. I'm talking about global. That will then change the climate or change the whole Earth system. So the last ice age that we have was about I think 40,000 years ago. Okay, and we just came out from the ice age. So you can see just near 0 there, that was the last ice age. So we just came out of the ice age nearly about 20,000 years ago. So what was it like in the ice age? Next. So in the ice age, carbon dioxide is low. So you imagine 20,000 years ago, or nearly 40,000 years ago, the last ice age, Malaysia is in the center of a continent called Sunda land. And that is why you see elephants in Sumatra, you see elephants in Malaysia, and that's because all those are linked by a land called Sunda. And so it plays an important part. And you can imagine our great grandfather was hunting mastodon that was living in our region. So you can see a mastodon there that I put. And how do we know about it? It's because from the cave paintings. Because our great grandfather also, some of them are good artists, so they paint. And from the painting, you can all see the sort of animals that are there. Next. So this was the last ice age. So now we are on the reverse. Instead of going to ice age, carbon dioxide is going up. And as you can see from that graph that I showed you, when carbon dioxide goes up, temperature goes up. When carbon dioxide goes down, temperature goes down. So now we are, because of our addiction to fossil fuel, carbon dioxide is now going up. So the trajectory of carbon dioxide that we are modeling. So these are models, okay? Now that we have very sophisticated models, and you can see in the graph, there are 4 trajectories. The purple one, the blue one, the green one, and the red one. The red one is as if you business as usual, you don't do anything. So which means that our temperature will be by 21st century will be about 4 degree warmer. And what we are hoping to do, and this is what you call the international community, they call it Paris Accord. We are trying to cap it to 1.5. So that means we are looking something like the blue trajectory. So the blue trajectory is what we are aiming for. That means a temperature rise of 1.5 in the 21st century. Because why scientists are worried about it? Because when you go at 4 degree, it's new territory for us. This is global warming, and we don't know whether even how our civilization or even how our globe is going to behave if the warming is 4, and it's lots of uncertainty if we go for 4 degree. So in the international community think that 1.5 is a more reasonable one. So that is the B1 that you see here. Okay, so that's what we are aiming for. So as you can see in the B1, when you look at A2, you can see there's more red. This is and when you see by 21st century, the one on to my right, I think the more extreme one, the 21st century one, you can see the B1 is not as red as the rest. So we are hoping to do that, and that's why there's now move to cut down on carbon dioxide emission. There's move to go to from fossil car to electric cars. All this is because the international community think we should try and maintain it to the B1 scenario. Okay, I hope, and that because I'm going to be dead by then. So this is the problem that you, the younger set, have to look into. Next. Okay, one thing about global warming, not all places are going to be warm, because when you have global warming, you have the change in the climate, and some changes in climate will make the place cooler actually instead of warmer. And so you can see, let's say here you can see the West US side is cooler in comparison. Yeah, can see that it's cooler, while the reddish color one is the one that is warmer. And the thing that you see is that the Arctic is very warm, warm up to about what 3 or 4 degrees. So this is measured. This is not model. The one that I showed you earlier is model. Next. Okay, so with global warming, sea level also will rise, and the sea level will rise because of 2 things. One, water will expand. So when the temperature goes up, 50% of the sea will expand, 50%. And then also because of warming, all the glaciers, especially in the continent, and also the glaciers in the Arctic, will start to melt. And when they melt, of course, the water goes into the sea. So you add more water to the sea, then the sea also expand because temperature increase. So all that contribute to sea level rise. And sea level rise is about 3.2 mm per year. That sounds very small, 3.2 mm. But if it continually rise for, let's say, 100 years, you're talking maybe about 1 meter or 5 meter of water of sea level rise. And some of the main problem is, of course, most of our tourist area and most of our big cities are by the coast, and of course that means that they will then especially people islands like Maldives, which is not very or even Singapore, which is not very, doesn't have a lot of highland. So you can imagine quite a lot of inundation that is going to occur. And of course, some of the place getting inundated, lots of people. So where are the people going to move when their place become the sea? Next. So climate, especially temperature and precipitation or rain, will then control what sort of ecosystem or what sort of trees, what sort of plant that will grow in the area. So you can see that when it's, let's say, temperature is hot and it's very wet, just like in Malaysia, you have tropical rainforests, evergreen rainforest. You go in, everything grows here. But when it is dry and hot, very dry and hot, then you have the Sahara, which is a desert. Okay. So as you go colder and colder, you find that you will have less tree. So when you go to just to give you a glimpse of the biome, I think so you can understand the relationship. So let me go to the next slide where just look at the biome. So when it's cold and just a bit wet, they're not. I mean, if you go to the Arctic, the amount of rain is maybe about 200 or 300 per year compared to us, which is 1,000, 2,000, 3,000. So, about 10%, no, yeah, 10% or 1% of what we have. Then it become a cold desert. Like Antarctic is a cold desert. Nothing grows there. So, and the amount of rainfall that the Antarctic gets is maybe what 200 or 100 per year compared to or even less. But the main problem is why it's called tundra is that the snow never melt, and so that's where you have glaciers being formed, because as the snow get compact, it becomes solid ice, and then it doesn't go away. So you can see in tundra, you can see the mountain is always white even though it's summer. And tundra has its own ecology. So you have a polar bear living there, that sort of thing lah. But if it warms up, then you will then change the ecology in the tundra, and that will have an impact not only on those animals living there, but also us human beings. There are quite a lot of people that make a living, Eskimos and whatever, and Inuits that use reindeer, even your Santa Claus. So he needs to think what to do if the Arctic warm up. Next. Now, if you go to UK or in the US, of course, you have temperate forest biome. For temperate area, you have the season, you have all the winter, summer. But what happens is that when you have this one, I think when you have the green one is more of autumn. So you have deciduous forest, and it also has its own ecosystem. So it's what you call temperate forest biome. The next one, and you have, of course, the desert where it's hot but very dry, no water. And as you can see, when you have no water, you don't have many trees and you don't have as much biodiversity. And of course, the last one is ours, which is the tropical forest bio. And that's why we are what you call the mega bio of the world, because tropical rainforest has the greatest amount of species and support the greatest amount of life. And that is an important heritage that I mean I'm a meteorologist, but I'm also an environmentalist, and I really hope that the future generation, will know how to look after the heritage. I mean, sometime I think my generation is not that good. We cut down quite a lot of forests already, but I think we need to we need to think how to conserve our biodiversity, because Malaysia is one of the epicenters of biodiversity. When you go, and I'm not talking just our forests, I'm talking also our ocean. Do you know that 70% of the species of coral in the whole world exist just outside in the South China Sea area? and of course in the barrier reef area, and this is known as the coral triangle, and that's where most of the coral species are, 70% of the globe. And when you look at in terms of the number of species, you know, I like, you can see later that I like to go birding. You know, we have about 300 or 400 species of bird in our forest, so we need to conserve this. I mean, this is something that I'm quite passionate about. Next. So what I'm trying to get at is global warming impact not only on the climate, it impact on our ecosystem, and it impact on all aspect of life, including us. Because you know, when you think about disease like malaria or dengue, they are also climate dependent. So when you have a warmer climate, you tend to have more dengue, and that's why dengue peaks in June for us. And and also the fact that when the, let's say, people in UK get warmer climate, then they also might get dengue fever, because you know, because the mosquito then can survive over there instead of just over in our region. So you know, it's also a health problem. You know, all sort of problems can arise from this global warming problem. So it's a very complex thing. It's the biggest challenge that humanity and the globe is facing at the moment. Next. If all the Earth's ice melt, you're talking about 60 meter of water. If all the ice in the ice cap melt, especially in the Antarctic, so 60 meter, KL also will be finished. How do you measure climate? It's very simple. You just take what is the weather. That means you take the temperature, daily temperature, and the daily rainfall, and then you add up 30 years of it. That is your climate. So climate is average weather. Next. Okay. Can I continue now? Tsunami has nothing to do with weather. It's more with earthquake. Okay. Next. NASA does the whole monitoring of the globe for us, and also ESA, the European Space Agency, and also the Chinese, and also some of the Indian satellites. So we use quite a lot of satellite data. When you saw the cartoon of the meteorologist, I use a lot of satellite data. I use a lot of rainfall data that you measure from space. They call it TRMM. But you know, the main problem is all this satellite. The average is only about 20 years, so it's not ideal. You know, you don't get the whole. I mean, it'd be nice if I have 100 years of satellite data, but that is not possible. So I can only get it from station. In Malaysia, the station start measuring atmospheric rainfall, temperature. The one that's good is only in 1950s, maybe. In some area in Taiping, maybe we can get data until 1950s. So observation is limited. But in UK, when you go to Kew Garden, we can get until 18th century. So we tend to use lots of data. Next. Biome is the interaction between the ecosystem and the climate. So, you know, when you have a particular climate, you tend to have a particular ecosystem. You tend to have a particular plants. You will have a particular animals, and so that is the interaction between the climate and the ecosystem. Okay. Volcanoes have, because when volcanoes explode, it will then pack up aerosol, and when you have aerosol acts differently. Aerosol will cool the air, will cool the earth. In fact, when you have the Pinatubo explosion from the Philippines, 2 years we were a bit cooler than normal, about 0.5 degree cooler globally. So volcanoes can cool the earth. So So you instead of global warming, you're talking about global cooling when you have so much volcano exploding. Earthquake has nothing to do with climate. Earthquake is more with plate tectonic. How the earth move. The earth consists of plates. It's just like your normal plate lah. And then where it interact, especially near the ring of fire, then that's where you have your earthquake. Because they build up tension, and then suddenly the earth move up or down, and that of course cause your earthquake. Okay. Oh, that's during what I showed you is in summer. So in summer, in the tundra, summer, there's enough sunshine to melt the water, but not in the Arctic though. But still, because in order to melt water, it just be higher than 0 degree, so the water melts lah. And so in summer in the Arctic, you do have enough sunshine to melt the water, and that's why you have the tundra, and becomes very fertile actually. So a lot of birds goes to migrate to the Arctic during the summer to feed. Okay, can I now go? I like staying in Malaysia. So there's no season in Malaysia. Okay, can I continue? Okay, so as you see, I am a senior research fellow at the IOES, Institute of Ocean and Earth Sciences. So I work on weather and climate, trying to understand weather climate in Southeast Asia. But I also, as a meteorologist and a director of the National Antarctic Research Center, I also work in the Antarctic. So I work basically right around the globe. I'm very privileged actually. So next. And I work on extreme weather, both in the Antarctic and also in the South China Sea. And the Antarctic, of course, is called katabatic wind and barrier wind. And that's where the wind can go right up to maybe 20 meters per second, which is about 40 miles per hour wind. So quite exciting for me lah, as a meteorologist. Next. And so this is where I go to put down my equipment, and this is where I was in the Antarctic. And being director of Antarctic, the Malaysian has for 20 years, we have been sending people to work in the Antarctic, not only in weather, but in biology. So I myself have been to the Antarctic about 13 times. So I think I still hold the record for about 13 years. So I've been going to the Antarctic from 1999 until 2011. But now I'm old already, so I now send people to the Antarctic. I don't go myself. Next. And sometimes because going there too often, I become tourist. So you can see there is the former Agong, Sultan Mizan, right? The one with the yellow speck. And then the next one is the Minister of Science then, Maximus Onkili. And that was the trip that we took them to, just to let some of our leaders know about the Antarctic, so that and it's really quite an incredible place. So I think the Agong was so excited about being in the Antarctic. Next. So back to just being a tourist, I do research though. And my main research is the one at the top, which is teleconnection between equatorial and polar climate variabilities. And then while my other colleagues are doing, I think UKM is doing on global lightning activities. So they want to compare the global lightning over in Malaysia, what are the mechanism and the global modeling, the global lightning up in the Antarctic. So they put their instrument to measure lightning. And then of course we are also interested to see whether the sea ice, this is in winter, what happened, the ice freezes, and that would then change the climate. So we have people from Utah and MMU, looking into remote sensing of sea ice and to see, how does that relate to the climate. Next, and of course, the biggest chunk of our Malaysian, we're a lot of biologists. So next, I won't go into it because I'm not a biologist. So we can lots and lots of research in terms of biology, looking at how climate change in the Antarctic impact. And you can see Malaysian there working on. The only one that is working on the climate is myself, right at the end there. You can see me putting a automatic weather station, but the rest are all biologists all over the place in the Antarctic, looking at soil sample, next one, looking at penguins poo, looking, trying to see what the penguin poo is like, because you cannot catch the penguin and bring it here. So we go and study penguin poo so that we know what sort of thing it eats. And that also has something to do with climate, because if the climate changes, then the penguin, which feeds on very small prawn, they call krills. If the krills population goes down, then the penguin basically will starve, and you have very bad breeding season, and so the penguin population goes through cycle that is very dependent on the availability of krills. So this is, I mean, if you, I think you I think that there was that movie, isn't it, about penguins, and it's quite related to krills because penguin eat lots of krills. So is your whales, and so there's whales there. But it's a really incredible place to work. And I think if May can get some of the younger scientists who are working in the Antarctic to come and share some of their experience, I can get that for you lah, as just to. But there's quite a lot of biology people, okay, not climate. While the group that works on climate is mine, and my group lah, and a few others lah, in Malaysia. Okay, and we've been working on it for years. So I'd like now to share you also what I do in Malaysia. As I said, we have the Gore station. I was involved in some cruises because we are interested in where the ozone, because the export of ozone and where the ozone is put into the stratosphere to work, to be taken to the Arctic, the polar region, to destroy your ozone. The input is from here, and so I was involved with the German to look into what you call short-lived halocarbon. That is different chemicals that can destroy ozone. And I also built a GOR station, which is Global Atmospheric Watch Station, at the Bachok Marine Research Station, somewhere in Kuantan. Okay, next I'm a bit short of time. Okay, so this Bachok Marine Research Station, where I do quite a lot of my research work on gases, greenhouse gases. And you are more than welcome to visit this station. If you write to us in iOS, we can get you some trips, and you can then visit my GOR station, which is the tower right in the center there. Okay, next. I'm fighting for time. And of course, here I chase storms. I'm interested in the flooding, you see. Next. And when you chase storm, you fly balloon with sensors on it, and every one sensor cost me about 1,000 ringgit. And at one sitting, I can fly maybe 20 sensors, 20 balloon, and that will cost me 20,000 ringgit, just gone, just like that. So it's a very expensive toy to play with. Next. And then this is the rain. We are more interested in the flooding. So flooding, of course, occur during the northeast monsoon. Next. So the component of flooding, I mean, I'll go very quickly. So you need some vortex. You need the rain band needs to be there for a long period. That means you need to rain for not only half an hour or an hour like your normal thunderstorm. You need to rain maybe that one day you rain maybe 48 hours, and that's how flooding is caused. And also where the rainfall is important, because if the rainfall in the highlands, the water level rise is much higher, as what you can see in Temerloh or what you can see in the 2014 case. Okay, sorry for the noise, somebody is working outside. Okay, next. And of course, to link it all, you work on, of course, climate, how the climate works between the Arctic and the region here. So this also, I'm also heading it. Okay, next. And the last thing, of course, I also work on air pollution. And of course, when you work on air pollution, the biggest air pollution that you work on is what you call the haze. Next. And this is the haze. And you can see the haze not only has an impact in our region, but its impact globally. And you can see the haze going all the way to Ceylon and all the way to Africa. So it is a very important. I mean, we when we burn, as you can see, we burn not, like you burn in your backyard. You're talking about 20 kilometers of forest being burned, and the impact, or impact is worldwide. And so it's a major disaster. That's what I call biomass burning disaster. And that's one that I was involved also in advising the government on the issue. Okay, so apart from being a researcher, I'm also involved in trying some of the policies that the government can undertake, and also the measurement. Okay, and the health impact of the haze. So we also have some outreach that to the Arctic that you can participate. So this one is run by Yayasan Penyelidikan Antarctic Sultan Mizan. So you can Google that, Sultan Yayasan Antarctic Sultan Mizan. Yayasan Pendidikan Antarctic Sultan Mizan, YPASM. So you can Google it, and if you are in Terengganu, you can participate in this what you call experience, where we send 2 students plus a teacher to the Antarctic. I mean, to the Arctic. Next. Okay, just to get you, I used to be a kid, and I stayed in a very small town called Jitra, which is in the Kedah, north of Kedah, very about 24 kilometers in the near the border. And my favorite, next. So this is my hometown. That's my old house, no longer there, and that's my late mother. And that's the river that I like to fish. And of course, nice thing about Jitra, you go just outside Jitra, 2 or 3 minutes, you hit the Bendang lah. And I love fishing when I was young. But now I'm old already. I'm stuck in KL. I'm staying in KL since 1983. But as they say, you cannot take the kampung boy from me. Next. And because of me being a kampung boy nowadays, I like birding. I like wildlife. So I go around wherever I go. Even when I go to my field trip, I will bring my camera along. I have quite a nice camera system, and wherever I chance to see some wildlife, especially birds, I will take the birds. So all these photos, including the orang utan that I showed you, are all mine. So it's not taken from some Google somewhere. Next. Okay, so the take home that I want to tell you is that global warming is not going to go away, and it's going to impact our life. So people must be more aware of climate and more aware of weather, because weather is climate. Climate is average of weather. And the issue of global warming comes from greenhouse gases, especially carbon dioxide and methane. And that comes out, we've been emitting it since 18th century. And this is what you call our addiction to fossil fuel. So we have to do something about this addiction. We have to try and maybe choose a different fuel system. So that's why you have electric vehicle, you have solar panel. People are talking about renewable energy. This just to get out of addicting ourselves to fossil fuel, because whenever you burn wood, you burn coal, you burn any sort of carbon-based fuel, you will produce carbon dioxide. And so we want to cut down on our carbon dioxide. And so this one, the climate will impact everything. And at the moment, because of development and all, we have major extinction. Some species are just disappearing within my lifetime. You know, you heard about the Sumatran rhinoceros, the last Sumatran rhinoceros that died in Kinabalu. You know, that's happening in my generation. So we are going to basically give it to you, to the younger generation, and my hope is that you are able to look it better than us lah. So far we are not really that good, so I'm sorry to you, but you need to, you know, I don't have that long to live anymore. So this is something that is a generational problem. You will then inherit it to your children. So we need to think in not only in terms of our own generation, is talking to my generation, but you need to think about what you are going to inherit to the future generation. Thank you very much. So this is my email. You can email me if you are interested to ask more questions. Thank you.
Wow, thank you so much for such
I'm within
an
time.
informative talk. We have a lot of questions for you. So why don't we take this time to answer some questions since we still have some time. So one is from Jitra.
Okay, what's the difference between climate change and global warming? As you can see in the first graph where I show you carbon dioxide and temperature, climate change is something that occurs naturally. But when you talk about global warming is something that is caused because of the human, because we put in more carbon dioxide than what is natural. And that is why you say global warming, because global warming is a human induced thing, while climate variability, you know, climate change is something that occur quite naturally, as I said. So they're two different things. But global warming then will change the climate, and that's the whole problem about trying to see what is the change. Is it associated with normal thing, with natural variability, or is it because of human being? And it's very difficult. It's not easy. So this way you need to study the change very carefully. But we have very, you know, the scientists are very clever. So they develop models, and it is from this model that we show that the increase that we see now is more due to the increase from us burning fossil fuel since the 18th century. And so this is due to us. But when we warm up the planet, as I showed in the other graph, some area is going, the climate will change. Some will be cooler, some will be warmer. So don't expect global warming that every place is going to be warm, because when you change the climate, you also change the temperature in that region. So this is what you call some of the subtleties of studying global warming that you need to do.
Okay, and next question.
Oh, well, one strategy, use less fossil fuel, more efficient energy, because energy is produced by fossil fuel burning. So anything that cut down on you using fossil fuel, more energy efficiency, because we burn in Malaysia, we burn gas, we burn oil, we burn coal to produce our electricity. So the more inefficient you use electricity, the more coal you burn. The next thing is renewable energy, because this renewable energy like hydro energy, hydropower, you know, we have 30% of hydropower. Things like solar panel, those sort of things don't burn fossil fuel. So that's why nowadays in Europe they're trying to go for electric vehicle, because they're trying to cut down on you burning fossil fuel. So the moment you put petrol in your car, you're already adding carbon dioxide to the air.
So these are all really good points. We actually have next upcoming series on solar panels and on renewable energy, on electric vehicles, everything that Prof Azizan talked about. So remember to sign up for these upcoming ones, or you can follow this, subscribe to this YouTube channel, because that's where we will stream the following Saturdays. But I think kind of referring back to this question, maybe for all the students who are here today, could you tell them something they can do specifically that will help to reduce impact on climate change?
It's an enormous problem. You're talking about you're talking about something that has been building up since 18th century. So what you can do actually is conserve your environment, conserve your forest, because the forest is a very good sink for carbon dioxide. A tree is a really good storage of carbon dioxide. The next thing that you can do is just take it granted that you're going to live in a warmer world. And as I told me, even if you cut down carbon dioxide to zero now, the temperature is going to rise. So we need to adapt. And so we need to know what to do when the temperature, let's say by 21st century, is going to be 1.5 to 2 degree warmer. The economy is going to be changed. The what you can do is going to be changed. Let's say you want to buy a piece of land by the coast, you think about twice about doing that, because that coast may disappear. So these are some of the things. Or zoning, that means if you think that you're going to get more rain, then when you want to construct a building, you tend to make sure that the building take into account that you're going to have more rain. Let's say when in the Philippines they're going to have more, they predict that they're going to have more typhoon. So what you do, you make building that is more typhoon resistant. So that's all the sort of things. So you just not only mitigating but adapting.
So that's a good lead on to the next question. In global warming, can people be saved or not by Quran?
Oh, you would die. I mean, the human civilization will go on. I mean, as much as our great grandfather had to survive in the ice age and survive, and then because of that we are now here. We have a population of 7 billion. So human being will survive, but it's the quality of survival that you are talking about. So don't worry, you still be human being in the 21st century, unless of course we blew ourselves up by having a nuclear war. Otherwise, you survive.
How can
Okay.
global warming extinct animals, says Seng Sujat?
Well, when you think about it's not just global warming, but it's also us not looking after environment. As an example, when you read a book by Gulick 100 years ago, there were tigers in Batu Cave, But now, because of tigers can't survive when you have only houses there and concrete, can't eat the concrete. So it's not just them having to what you call I mean, for the animals, once once they lose habitats, and then apart from that, they lose their food source. Like when you have, let's say, warmer Arctic becomes warmer, the polar bear, when it wants to hunt, it must hunt on the sea ice, because then it can go further to catch the seal. But when the Arctic gets warmer, the sea ice decrease, so the polar bear cannot hunt. So because it cannot hunt, it just die of starvation. So this how, in some sense, related, between global warming and extinction. And when I'm talking about extinction, I'm not we only realize extinction of big animals like polar bear and that sort of thing. But also, when you change the temperature, you also change the microbes, and that's the basic thing. So the microbe population changes. When the microbe population changes, it impact on higher order animals, and so that's how you talk about extinction. You just don't think just about the animals that you can see, the penguins, the dugong, but you need also to look at the microbes that will then change because of temperature changes.
Great. And that's all the time that we have for questions at the moment. Thank you so much, Prof Azizan. It has been so informative. I learned so much. I hope that everyone who joined here today has also learned a lot about global warming, climate change. If you have had the opportunity to ask the questions, I hope that you have a clearer picture of what global warming, climate change is about. So remember, next week we are going to talk about renewable energy. I think Prof Azizan talked about how important that is, because remember, when you burn fossil fuel, you have greenhouse gases, and that is causing the global warming. So we want to learn about what people are doing in the renewable energy space. So if you're interested, please join us. Subscribe to the channel. You will get notification on the live stream that we have next week. It is at the same time on Saturday, 10 a.m. So join us for that. Prof Azizan, thank you once again for joining us.
Thank you for having me.
It's been so great to have you. Thank you, everyone. Thanks, kids. Have a good weekend ahead. Thank you for joining us. Bye-bye.